Now that we've looked at various ways of making alcohols and oxidizing alcohols to ketones and aldehydes, we can think about retrosynthetic pathways of designing alcohols. So uh, this is something that sometimes takes a little bit of time to really think about. But if you're given a complex alcohol, oftentimes you'll be asked to design a synthesis of it from smaller alcohols. How do you go about doing this? Well, let's take an example of this particular alcohol. What if you were asked to design a synthesis of this from smaller alcohols? And I'll leave it at that. Most of the time it's going to be specified how many carbons the alcohol um, can actually contain. So you have to think about, what direction you want to take. So the question becomes then, well, how do I make this? And the answer is there are three different pathways that are possible and probable. Again, one of them may be better than the others because of the starting material that you have, that you're given to start with. So that's something to think about, and we'll look at some problems that deal with that. But the first thing that you have to do is kind of analyze the carbon that has the OH group. And in this particular example, we see that it's a tertiary alcohol. So how do we make tertiary alcohols? We make tertiary alcohols from ketones and Grignard reagents or organolithium reagents. And what you want to do here is you want to visualize the R groups coming off of that carbon and think about, um, the different ways that you can make these from ketones and Grignard reagents. So I've highlighted the alkyl group coming off on the right in blue, right? I have this ethyl group coming off in blue. And if I envision removing it, because we're doing a retrosynthetic analysis, we're not adding anything retrosynthetically, we have to almost think about removing it. Then the resulting ketone looks like this, right? Where you have the benzyl group coming off of that carbon and a methyl group coming off of the carbon. And you convert that carbon-oxygen bond to a carbonyl. This is the ketone that we start with. And of course, I know if I react that ketone with ethyl magnesium bromide, the Grignard, then I can get the alcohol that I'm striving to make. Now, notice I was asked to make that tertiary alcohol from smaller alcohols, so I could take and I could make the ketone from an alcohol because I just learned how to oxidize alcohols. And of course, I can make the Grignard from an alkyl bromide. So if I have ethyl magnesium bromide, I can make that from ethyl bromide, and I can make ethyl bromide from ethanol, right? And that is one of the paths that I can choose to make this particular tertiary alcohol. A second path is one of the other R groups is a methyl group. So again, thinking retrosynthetically, if I remove that R group, the ketone that I get looks like this, right? So the methyl group's been removed. I still have the benzyl group on, and I have the ethyl group on, and that carbon-oxygen bond is converted to a carbonyl. So if I react that ketone with methyl magnesium bromide, the methyls from the methyl that I removed, then I know I can make that tertiary alcohol. Again, thinking about, starting with alcohols, I can take that ketone, I can make that ketone from its corresponding alcohol, and I can make the Grignard from methyl bromide, which I can then make from methanol. And then the last path, the third path, is focusing on the benzyl substituent coming off of that carbon. So if I remove that, the ketone is 2-butanone, and I can react butanone with uh, benzyl magnesium bromide, and of course I can, to get my alcohol, and I can make butanone from 2-butanol, and I can make benzyl magnesium bromide from benzyl bromide, which I can then further make from benzyl alcohol. So you see three possibilities, three possible paths. Um, each one of them works, right? And it really depends on, um, what starting material you're given that, that's going to help you to decide the particular path that you want to take. Notice also, I could take those alcohols and I could, break them down even further into smaller components. So one of the things that you have to remember is you definitely have to remember reagents. How do you go from an alkyl how do you go from an alcohol to an alkyl halide? How do you go from an alcohol to a ketone or an aldehyde? Keeping reagents straight. The other thing that you have to remember is you cannot confuse oxidizing reagents with reducing reagents. This is a common mistake that students make, so make sure you have the oxidizing reagents, how to oxidize an alcohol to an aldehyde, how to reduce an aldehyde to an alcohol, how to oxidize an alcohol to a ketone, and vice versa. Keep those straight and practice those, because that is, something that takes a little bit of work to do.